Hello, welcome back to Cracking the Cryptic. Oh my goodness, what a struggle I had with that puzzle yesterday, and very much as I feared. Quite a lot of the comments were from people who explained that it was perfectly doable in somewhere between 12 and 20 minutes. So the hour I took, bit of an embarrassment, and thank you very much for the kind thoughts of people who say, listen, don't beat yourself up. You've been doing this for 5 years, and we like that you leave in the genuine solves. And I mean, I'm afraid I'm committed to doing that because I enjoy the genuine solves. I don't mind actually how long a puzzle takes. I mean, I sort of say I do at the end, but it's a tinge of embarrassment. But hey, it is what it is sometimes, and today could be yet another day when I struggle with a puzzle. We will see. We've got a lovely puzzle. Now, I did not understand the email we got recommending this puzzle didn't make it clear whether it was by the author of the email or whether the author of the email knew who Anon was who created this puzzle, but it may be an unknown author. Anyway, it looks interesting. I'm going to have a go at it. It is very much near symmetrical. I mean, the actual positioning of the dots, the quadruple clues and the cages in the puzzle is mirror symmetrical about the central vertical axis. And I'm looking forward to having a go at it, and we'll see if I can do any better than yesterday. But it, of course, depends on how difficult the puzzle is and how well I do with it, but we will see. Now, let's not forget that on Patreon there is still plenty of time to do the April Foolery puzzle hunt, difficult though it is, full of Sudokus with a bogus clue in. And definitely my tip is to find the bogus clue to make progress with each puzzle. That is the most important thing to do. Because all the others are genuine, that's why. Now, that's on Patreon, and today I have posted my crossword solve, my super hard crossword solve. The Times Monthly Club special is a cryptic that appears for Times Crossword Club members each month. Has the most insane vocabulary in it. I remark in the video on the previous month's puzzle where one of the across entries was thanatognomonic, and the author wrote to me after I had solved the puzzle and said, "Oh, I'm really sorry to make you struggle. I thought it was probably easier than normal." Yeah, well, thanatognomonic indeed. Anyway, that crossword is on Patreon. We do put crosswords and connections videos there, as well as some difficult long solves and the Sudoku hunts each month and solution videos for those. There's loads going on. Do check it out. Along with our merchandise, SVEN'S Sudoku Pad, all on the links under the video, and all of our apps, which feature Killer Sudoku, Domino Sudoku, and the latest Fog of War Sudoku. So reward yourself for being good all over the winter and enjoy some fun over the summer with those apps. We are working on something else, but it'll be a while coming to fruition, I think, in terms of the apps. But there will be more this year. Anyway, let's have a look at this puzzle and its rules. It's called Near Symmetry. Normal Sudoku rules apply. 1 to 9 in every row, every column, and every 3x3 box. Cells separated by a black dot have a 1 to 2 ratio, so one's double the other. Digits in a cage cannot include repeats and sum to the total given in the corner of the cage. So those 5 are different digits adding to 23. All the numbers inside one of the quadruple clue circles, 1, 2, and 3 in this case, must be in those surrounding 4 cells. So those are the rules. Give it a try. It's an interesting looking one. I'm going to start now. I don't know who Anon is. Maybe they'll reveal themselves in the comments afterwards. Let's get cracking. Okay, so those 1, 2, 3s are very suggestive. So this is something we know about quadruple clues, which is that if you get the same quadruple clue in the same row and column twice, that uses it up for that set of boxes. So if you think about the fact that 1, 2, and 3 must be positioned in those cells for those boxes, then that uses them up for boxes 1 and 3 and also for rows 1 and 2. And it means the 1, 2, 3 in row 3 must be in box 2. And that digit then will be 4 or 6. It cannot be 8. It cannot actually allow this to be a 1 because the 2 that would have to go there is definitely in one of those cells in that case. So this is either a 4-2 or a 6-3 pair, I reckon. Now, this digit, that's going to tell us. This digit is a 2 or a 4, and I know that because a sequence of black dots, 3 digits that have to be this. Excuse me a second, that's a very early and unnecessary interruption. Scam call of all things, very annoying. Right, this is either 1, 2, 4 or 2, 4, 8. But yes, I know that because there are 2 families of black dot digits. One is 1, 2, 4, 8 and one is 3, 6. Now, the fact that this is 2 or 4 means this cannot be a 2, 4 pair. It can't be a 2, 1 pair because 1 must be in one of those cells. And it must now be a 6, 3 pair. So I can write them in. That doesn't reveal what this 2 or 4 actually is. Now, there are, goodness me, how have I got this far without using 2 cell cages that add up to 3 and 4, which I can basically fill in? That's going to confine the 1, 2 in this box to those 2 cells. And the 1, 3 similarly in this box. I do like the near symmetry of this puzzle. I'm enjoying it so far. Now, there's a 1, 2 pair there and a 1, 2 pair there. So these cells include 1 and 2. I don't think 1 can go in a 19 cage. In fact, let's add up the bottom row. So, time for me to share with you a secret that belongs to the world, that every row, column and box in a Sudoku always adds to the same number. We always know what number that is. It's 45. So 19 plus 19 in this row is 38. That leaves 7 for these cells, and they must be a 1, 2, 4 triple. And that cannot now be 2. So this is now a 1, 2 pair. We can't quite get the same result with 1, 3, 1, 3, because 3 could go there. In fact, these 19 cages, how are they made up? One of them is going to include the number 3 because it has to appear in the bottom row somewhere. 19 minus 3 is 16. So one of these cages is 3, 7, 9. And one of them is 5, 6, 8. I don't think we know which is which yet. Oh, I might be able to rule 1 out of this. No, maybe not. 1, 9, 8 is possible there. That is telling me that this cell is 6 or 7 in the 8 cage. I haven't seen that. This black dot is seeing a 1, 2 pair. So this is either 4, 8 or 3, 6. If it's 3, 6, we know the order because of the 3 we got earlier. I don't know now. What's next? I haven't really been attacking this in a very orderly order. But that's the way the cookie crumbles sometimes. Right, one of these is 3, 7, 9. The other is 5, 6, 8. Is there any constraint over those? Oh, this black dot digit is not 1, 2 or 3. So again, that's 4, 6 or 8, just like this one. This, however, cannot be a 3, so that can't be 6. So this is down to 4 or 8, making this digit 2, 4 or 8. Yeah, it's different from over here because of 3 being in that box. The 18 down here, if that's a 2, this is a 9, 7 pair. If it's a 1, it's a 9, 8 pair. If it's a 4, it's a 5, 9 pair. It always includes 9, it seems. So 9's going to go in one of these 23 cages in the central box. So is 3 and 6. Oh, that's cool. Right. I'm going to try adding up these cages. What's going on here? So these cages add up to 46. Sorry, there's something odd going on with those cages and this column and stuff in this puzzle. And I don't know what it is. So I feel I'm being very dense here. What? Right, do the maths. That was the plan. Do the maths. My brain is frying trying to work out how that is connected to this. But let's just do the arithmetic. So the yellow cells add up to 46. These purple cells add up to 45. So yellow adds up to 1 more than purple. Let's cancel out these exact equivalent cells. Yellow adds up to exactly 1 more than purple. I don't think that's very helpful still. These two either add up to 3 or 4, and these two definitely add up to 3. So I think there's a difference of either 1 or 2 between the total of those two yellows and that purple, and I don't actually think that's not set theory I need to be doing. It's a very confused picture, let's put it that way. Okay, this digit can't be 1, 2 or 4. It's 3, 5, 6 or 7. Making this 3, 5, 2 or 1. That feels thoroughly uninteresting. Oh goodness, I'm getting a bit bogged down here now. I think it's just because I'm not thinking clearly about something. This 18 cage has a 1 or a 2 in it. Is that? 18 is not a useful total, and it becomes less useful once you put a low digit into it. One of these is a 4, because it's either 4, 8 or 2, 4. Yeah, I don't know. I'm really getting stuck now. Okay, is there some reason this can't be 1, 2, 4 or 2, 4, 8? It's going to definitely create a 1, 2, 4 triple on at least one side of it in column 4 or column 6. Is that the point? If we add up, I don't know. Right, those add up to 18, and obviously the column adds up to 45. These cells add up to 27. Take out the 9, and these ones add up to 18. Now maybe that's giving me some sort of overlap between my earlier comparison. That's 2. I don't know. It's a little unwieldy. Right, what did I discover earlier? 3, 6 and 9 are in these cells. So here we're selecting from 1, 5, 7 and not 1. Oh, there's a 1 X-wing. Oh, it's so blatant. Look at that. 1 in both of those. Sorry, 10 minutes not spotting this. one in row 6. I mean, it's exactly the same thing as I was talking about with the quadruple X-wing, but one has been used up in both rows 4 and 5. The one in row 6 is in this group of cells, so we can put 2 in the middle, 1, 4 aside. Now this is very surprising. We've got 1, 2, 4 triples in both columns. No other digits in those columns can be 1, 2, or 4. No, what's more, that's really interesting. Where do 1, 2, and 4 go in this column? One of them is there and one of them is there. Where is the third one? It's not in this box where 1, 2, 4 are already accounted for. It's not in this box where 1, 2, 4 are already accounted for. It's got to be in this box, and it's got to be there, and it's got to be 4. And this is a 1 down at the bottom, and that now, this is very neatly done, isn't it? That is a 9-8 pair to make up the 18 sum. I originally thought 1 couldn't be in it, and it's definitely in it. This is now 5, 7. Now we're going to add up these digits, which are 3, 6, 8, 9. They add up to 26, plus the 1, 2 we've already had. I'm going to work out what this is 29. These yellow cages that aren't yellow anymore added up to 46. So these remaining yellow cells, these remaining yellow cells, I'm not going to be able to work out what that is. These remaining yellow cells add up to 17. And they include a 4 somewhere, because of the pencil marking in the row. Oh, I thought this was going to just come out. Yes, hang on, maybe I can do it. They add up to 17. They can only include one digit from 1, 2, or 3, which is a 2 or a 3. So the minimum is 2, 4, 5, 6. That does add up to 17. Right, do you see why the minimum is 2, 4, 5, 6? 1 has been used up here. So we can't have a 1 in those cells. It's the 2 1s for the rows have been used up. And one of these is 2 or 3. So the absolute minimum we can have is a 2, but not a 3. And then the next cells are 4, 5, and 6. And that is what these have to add up to. So they are 2, 4, 5, 6. That's a 1. This is going to unwind quite a few bits and bobs. 1 and 3 there. Now, these cells can't include 6, and this one can't include 5, and is a 7. This is a lovely puzzle. I really like how this is unfolding. These can't have a 2 in. These do have a 2 in, and that digit in the same cage must be 1. So that's 2. Now, not only must that be 1, this cage has got a 1 and a 2 in, and the other 3 digits have to add up to 20. They cannot include a set. Now, there are ways of adding to 20, but there's only one way of adding to 20 without using a 9, and that's 5, 7, 8. This is in the remaining 3 cells of this cage. Now I know that from the pencil mark, 5, 7, 8 cannot exist here because 7 is blocking all of those cells. So 9 must be in this cage and therefore can't be in this one. And now I must be able to work out, if I add up all of 2, 3, 4, 5, 6, 8, that will come to a number that's a little more than 23. And I can take out the 1 digit that can't be in it. So 2, 3, 4, 5, 6, 8 add up to 28. Minus the 23 total for the cage, I remove 5 from the cage. And it consists of 2, 3, 4, 6, 8. That's a 4, 6 pair. This is a 3, 8 pair. That 4, 6 pair sees this pair, which is a 2, 5 pair. I can get rid of 3 and 8 from those cells, and we have 9 and 6 left. Oh, this is brilliant. Now, I must be able to disambiguate 8 and 3. That's thanks to the 3 here. Now, this can't be a 3. This is definitely a 4, 8 pair. That's a 6, 4, 8, 4. That makes this 8, 4. Oh, I love how this unwinds. This is so elegant. That 1 has sorted out those 1, 2, 4 triples completely. There they are. Now, this can't be 6 anymore. This one is still able to be either of its candidates. Now, what was going on down here? We had a 3, 7, 9 in one of them. The other is 5, 6, 8. Yeah, okay, I don't know which is which yet. The 1, 2 pairs, these are 18 cages. Where do we go next? I'm scouting around. One of those is an 8. One of those is a 9. This is from 5, 6, 7. This is from 3, 5, 7. Got this sort of weird 3, 5, 6, 7 quad. Oh, let's think. Okay, these are all high. 6, 7, 8, 9 are remaining. On this side, 3, 5, 7, 9. But this cage, the minimum of those two cells adds up to 13. So the maximum for these two adds up to 5. But it can only use one of 1 or 2. So it can't add up to 3. This adds up to either 3 or 4. Hang on. No, to either 4 or 5. It can't add up to 3. This adds up to either 4 or 5. So this pair adds up to 14 or 13. It's either 6, 8 or 6, 7. That's not a 6 and... Oh no, I was going to say it's a 9. Don't know that. And this pair could be 1, 3. No, it can't be 1, 3 because of that. Looking at that cell. So it's either 2, 3 that way round or 1, 4. Either way, it always adds up to 5. This pair always adds up to 5. So this pair always adds up to 13 and is a 6, 7 pair. That's a 9. Oh, brilliant puzzle. That's an 8. There's no 7 in this group. The 7 in the box is there. They add up to 5, and that's the other digit from 1 or 2 in the row. 8 has ended up in one of those two cells. Now, what about this 18 cage? It's either 3, 5, and these add up to 10. That would be an 8 then, because it, I know, 8 or 9. Or this is 3, 9, and these add up to 6. With the pair that adds up to 5 here, that would be 1, 2, 3, 5. That would be a 5. So even if that's 3, 9, there's a 5 in the cage. If this is 5, 9, that's impossible, because this would have to be a 1, 3 pair and break that cell. So this is not 5, 9. There is a 3 in this cage. Actually, that was doable by noticing the 3 down there. Bother. And this is either a 9 or an 8, if that adds up to 10, or 8, no, 12, 13 or 14. This would be 4 or 5. Well, it can't be 4, so it might be 5. Oh, I thought that was going to be a little more forthcoming. Oh, 6 in this. Oh, look, 8. 8 has to be in one of those two cells, yes. Right, so these are from 5, 6, 7, 9, but 6 can't be in those two. 7 can't be there. So, 4, yes, 4 is also up there as well. 2, 4 there. So the remaining cells here are 5, 6, 7, 9 as well, just like here. 6, oh, yeah, no, 6 is ruled out of those. 6 has to be in one of those two. So it's ruled out of those two. 6 is also ruled out of that one. I can place 6. overexcited about a 6. No, that looks down and gets 6 in box 4 as well. Now 6 is in one of those cells. Can we do any more in this column? I bet we can now. That's not a 7. 7's in one of those cells, so that's not 7. 6, 8, 4, 7, 1, 2. This is 3, 5, or 9. What were the totals for these cages? One is 3, 7, 9, and the other is 5, 6, 8. Oh, they're nearly getting resolved. Not quite. 1, 2, 3, 4, 6, 8, 9. Oh, I don't know quite where I am now. I haven't really used these 8 cages properly at all. Is that getting constrained? Not really. That pair adds to 5. That's, maybe it's row 7. Maybe it's row 7. I don't know. I don't know what it is. What am I meant to be finding now? There's some clue that I'm just not using. But there's only cages left, I think. I've used the quadruples. I've used the black dots. They're fully populated. Yeah, there's only cages left. I can get rid of all those colours. They weren't really right, were they? 2, 1, 3, 8. It's going to be something like, where is 8 in this row? It's either there or it's here, in which case these are both odd. I mean, that's quite interesting. These, what did we say these added up to? Either 10 or 6. Can they be 1, 5? That's maybe the interesting question. Hang on, if that's 3, 9, this is 1, 5. If that's 3, 5, oh yeah, this could be 2, 8. There is still a possibility. Right, can these be 1, 5? That would be 2, 3. That would be 7. That would be 6. 9, 8, 4. It does just work. Okay, let's go slower. 9, that can't be 9. Of this. 1, 3, 9, 6. 8 is in one of those cells. 1, 2, 7, 4. Oh, maybe I can do these cells at the bottom and I just don't know how. Or, actually much more plausibly, maybe some 1, 2 or 4. Look, 4 is definitely in one of those 2 cells in box 7. I hadn't noticed that. So if that was 2, 3, this is a 4. Then 8 would be forced into this cage, which would be a 5, 6, 8 cage. Oh, if it's a 5, 6, 8 cage, we know the order. 5 there, 8 here, 6 here. If this is a 5, 8, 6 cage, we know the order. 5 there, 8 here, 6 here. And I'm spotting that because of the 8 pair up here. Right, so if it's 5, 8, 6, those are the orders. Now, if they're 3, 7, 9, do we know much about them? I've got 3 and 3. That would have to be 3. So that would be 7, that would be 9 on this side. On this side, I've got a 3 there, 7 there, and 7 there. That would be 7. This would be a 3, 9 pair, and I don't know the order. This is where the symmetry is near, but not quite. Now, are those pencil marks going to do anything? 4 is in one of those 2 cells. I've only just seen that. 1, 2, 7, 4. I don't think these pencil marks are going to help. I mean, they were quite hard won. Ah, but wait, these digits are all from 5769. In this column, we've used 24138. Now, this can't, if that was a 379 cage, this would be 56. Yeah, this can't be a 379 cage, because that would be 56. There's nowhere for 248 if this is a 379 cage in this box. That's the point. You can't fit 248 into two cells. Right, so this is not the 379 cage. This is the 586 cage. This is the 739 cage. And that's going to finish us off somehow. We can't have a 6 there. We can't have a 5 here. Now I've got a 1-3 pair. That means we can't have 3 in this cell. And 3 is placed in that box. And now that's a 1-4 pair. This is a 2. I'm not going to go crazy on this cage. No, I can. That has to be the same parity as that because of the parity equivalence up there. Yes, okay. That's now 5, 3, this is 6, and this is now just filling in, which is exactly the stage of the puzzle I like to get to, if I'm honest. That's a 9. This cage had better add up. It does. Good. This is 6, 4. There we go. This is 2, 9 over here. There we go. This digit's a 5. That's 7. That's 9. Why are these not done? I think this column is going to do them. 6 there. This row is finished with a 9. That is going to do the pairs down below. Actually, this pair's done as well. So it's just the top 3 rows. Just those original quadruples really left to sort out now. Via this box maybe? Yes, 7 and 8 here. Although I can't put those in. But 9 and 5 here, and I can put those in. That's going to sort out 5, 7, 7 as. So often the last few pairs in the same rows unwind together. And there we go. What a lovely puzzle by Anon. I'd love to know who you are, Anon, because that's really interesting. I mean, I think that has a lovely flow and feel to it. And yeah, very elegant. Somehow I've never seen that trick before with these 1, 2, 4 there, 1, 2, 4 there, and then those being forced to be from 1, 2, 4, giving me that. That was very, I don't know why, that was a very neat structure, little tower structure in the middle. Beautiful puzzle. I've really enjoyed that. I hope you've got something out of it too. And a pleasure to be able to bring these to you every day. Thank you for watching, and bye for now.